Hello, people. So today I'm going to be talking about congruence and similarity. This is part one of at least four on congruence on Diwali. This is the first year of this mini series, I guess, or is it a series? I don't know, series. Anyways, so we're going to be talking about congruence and similarity. Duh. So what is congruence? This is the congruent symbol. By the way, not the congruence. I made this myself. This is the congruent symbol. This is the congruent symbol. Anyways, so in geometry, my handwriting will write two figures like this. Hold up. Like this. Like this are congruent, close enough, are congruent if they have the same size, and this is the big and shape as the other. This is a version of similarity, a subset. Hold. That's it. Anyways, a subset of similarity. So, wait, hold up. There's another condition. Or the mirror image. Holy shit, what happened to my eye? Anyways, whatever that was. Oh, it's gunk. Whichever. That was long pause for no reason. Anyways, this is because, like, see this. Golden. And this. Assume they're congruent. Also golden. But I cannot conform this into this. Don't worry, children. You can just flip it from the third dimension. Easy as that. And that will still mean it's congruent. Let's freaking go. So, now that we've got that, now for the formal definition with isometries and all that. Oh shit. Diwali bhaiya ne mere saath acha nahi kiya. Two sets of points. Yes, points. Not even shapes, points. As we got are congruent if and only if. Yes, that's the if and only safe symbol. One can be transformed. Hold up. Oh, come on, focus. Anyways, focus, cameraman. Wait, hold up, I am the camera. Into the other by an isometry. What's an isometry, you'll be thinking? Well, an isometry is a rigid motion. Most specifically, it's a combination of rigid motions. Now, you'll be thinking, what is a rigid transformation or a motion? It's a geometric transformation of a Euclidean space that preserves the Euclidean distance between every pair of points. Easy as that. So basically, if I have this point and this point in a rigid motion, the distance d, the word b, cannot change. The distance cannot change. Whatever happens, it cannot change. Seriously. A translation, a motion is a type of rigid motion. A rotation is a type of rigid. Wait, did I stutter? A rotation or rotary or rotational motion is a type of rigid motion. A reflection, basically, what do you basically think of a mirror image, even though it's not? Is a mirror is a rigid motion? This means that either object can be repositioned and reflected, but not resized. But not resized. That's the difference between similarity and congruence. Sorry, Mr. Point. I'm so sorry for stopping you. So as they are coincide precisely with the other object, that's by the same size. They have to be the same size. If it's the same shape, it's in here, here. That is not. I just mean to. You know what I mean. It's in here, 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 and also possibly here. But if it has the same shape and the same size, it's in here. It's in here. Congruence is a subset of similarity. Anyways, that I've got that out of my system. On to page number B. Therefore, two distinct plane figures on a piece of paper or any other thing that you might want, like this. This is not a polygon, by the way. I just wanted a figure. You my children, figures are important. Hold up. Yes, like I was saying. A congruent if they can be cut out and then matched up completely. Turning the paper over is permitted, by the way. Same for similarity. We have a lot of congruence criteria, but we don't have time for that in the video. Now for similarity. Similarity is congruence big and extremely goated brother. It's the greatest of all time. Two objects are similar if they have the same shape, or if one has the same shape as the mirror image of the other, or more precisely in mathematical language, one can be obtained from the other by uniformly scaling, enlarging or reducing, possibly with addition, translation, rotary motion or rotation. Yes, that's how I do that. I'm sorry. On reflection. This means that one either object can be resealed, repositioned, and reflected so as to coincide precisely with the other object. If two objects are similar, each is congruent to the result of the peculiar uniform scaling of the other. Hold up, that sounded like I was reading us off of Wikipedia. You have a great day, children. That is all from Professor Jaskros. Thank you, Professor Jaskros. Anyways, this is a sign for congruence, and this goaded thing is a sign for similarity. Yes, it looks like they're approximately equal to symbol, by the way. It's goaded. Have a great day, children. By the promotion.